Hello, Chem students. In this little PowerPoint presentation, I'm going to look at drawing fairly long 2D structures. Sometimes I have problems like this on the exam, and maybe this will help you be able to do those problems. Number one is you have to be familiar with the functional groups. So I have all the functional groups listed here, and actually I have them listed in priority of nomenclature. So over here I have a group, but I don't have the name of it. I have the names mixed up over here so you can try and guess what it is. And on the next slide, you can see that I actually have the names with the group so that you can check yourself. So if we look at this first slide, this would be a carboxylic acid. So I would come over here and say number 2. The second group is an anhydride, acid chloride, and so forth. So you could go through and test yourself on all those. It's really helpful if you know what those groups look like when you're trying to draw a 2D structure, because you have a good idea of what the possibilities are. And if you don't have those good ideas, then you probably won't do well on a problem like this one on the exam. So these are the functional groups we're responsible for. And like I said, here's the answers. And so you could go back and forth. You could test yourself here. What is this group? This group is an aldehyde. Okay. And I also have that little Quizlet link that's in Blackboard that you can take a look at for the little note cards to test yourself. Okay, so I'm going to make an assumption now that you do know the functional groups. You're pretty comfortable with them. So let's take a look at an exam type problem that we might have. So that you can see this is a very long string of letters here. Okay. These letters all represent different functionality in organic chemistry. And so what I'm trying to get you to do is recognize how to make the breaks and locate the different patterns that you're looking for. Remember, we only have 15 or so functional groups that we're responsible for. So knowing the functional groups help. Now, if I look at this first part right here, I see two CH3s. These are single bonding groups, just like a hydrogen. They make one bond. And then I have a carbon, so it's got these two groups, and then it has an H. So these three groups are all on this carbon. And this whole group then is connected to this carbon right here. So that would be the finish of this guy. You could write that out, which we'll do in just a minute. Then I have a CO with nothing else. So very likely this is a C double bond O off to the side. All right. C double bond O is a very common pattern in organic chemistry. Let's go back and take a look just a minute. So if we go back here, notice C double bond O, double bond O, double bond O, double bond O, double bond O. Okay, so we have acids, anhydrides, acid chlorides, esters, amides. Amides could be primary, secondary, or tertiary depending on how many carbons. This is a primary because there's only one carbon attached to the amide. And then we have aldehydes and ketones. So when you see a CO type linkage, a possibility, a good possibility, is that it's a carbon-oxygen double bond, which we call carbonyl. Then I come to another carbon, but I only have this group here, and the C double bond O, and another carbon. So it looks like there's three groups here. So I'm thinking that this one is going to be the same, and this is going to be a double bond. Okay? And then I come to these two carbons, which are pretty sparse. There's not much on them, and so that's probably a triple bond. Probably the extra two bonds are between these guys. And this is connected to a C with two O's. Now this is a common place for a mistake. The mistakes are you put an oxygen up and down and continue on, and then there's no way to quench the minus charge that you have on those oxygens. Or you put a carbon-oxygen-oxygen linkage with a peroxide linkage, which is pretty uncommon, pretty unstable, and I don't have enough bonds to fill in this carbon. So this is another case where I have a C double bond O, and then the other O is connected to that carbon as well, and continues on, and that'll be an ester. Now this is actually a pretty easy one here, because the carbon's connected to the one in front, and then it has an H, and then it has this group, that's 3, and then it's connected to the next carbon. So this is a fully contained carbon with a C triple bond in off to the side, which we call nitrile. And then I have a CH, and then another unit that has to be off to the side, NH2. Okay. And then that's connected to this carbon. And this is another pretty easy one because I have an H and then the OCH3, which is an ether linkage, and then it's connected to the other carbon over here. Now this is kind of like the double bond, the two oxygens back here, where I have a CON. Because both of these are connected to the carbon, I have a little bit of a problem because I can only write one of them at a time connected to the carbon. So I take the C double bond O and use the end, and then that continues on down. Okay, so this is going to be an amide linkage. And then besides the H, the amide's going to be connected to this group right here. And when I see the C6H4, I'm thinking this is going to be a ring. This is going to be an aromatic ring, okay, which is alternating double and single bonds. So that's a common one that I stick into the chain. And then here's another CH with a group. Okay, so this will be an aldehyde group off to the side. If you're familiar with the aldehydes, it won't be too bad. And then I have a CH with an OH, that's an alcohol. So this will be a CH alcohol off to the side. And then I continue to this carbon. And then I get the two oxygens, and this time an H. So if we look back here, I had the two oxygens and a carbon. That was an ester. This time I have a C double bond O, and then I continue with the OH. Okay, so what that's going to look like is something like this. Now here I drew in all of the breaks that I would put in myself as I go down the line, places where I recognize patterns. And so that's what you're trying to do. You're trying to see those patterns that are in there. But let's see how it all goes together with the 2D structure. Okay, so here's our original structure. Here's our hints with the breaks. And this is the way it would look if you drew it out as a 2D structure. So here is this group here with two methyls and an H. Okay, and that's connected to the C double bond O. That's a ketone. And then that's connected to a carbon with a methyl off to the side, and the carbon connected over here with a hydrogen. So they need another bond, and there's going to be a double bond between them. And then I come to this pretty bare spot of two carbons without much else, and that's going to be a carbon-carbon triple bond, an alkyne. And then I come to a carbon with two oxygens. So here again, it's what I was mentioning. C double bond O, and then the O continues on down the line. In this case, there's a carbon on the other side, so this will be an ester linkage. And then I come to a CH, and then in parentheses I have the CN, so that's going to require a triple bond between those two, and that's going to be a nitrile. And then I come to a CH and an NH2, and so that's going to be, the NH2 is off to the side because otherwise the nitrogen would have 4 bonds. Okay, and that's going to be an amine. And then I come to a CH, and I put in parentheses the OCH3, so that'll be off to the side. That's an ether linkage. And then I come to the CON. So again, that's going to be a C double bond O. That's a dead end. But then the nitrogen has the H and continues on to this 6-carbon ring. So when you see the C6H4, there's going to be a lot of carbons in that ring, 6 of them. And because there's just a few hydrogens, there's a lot of what we call unsaturation, pi bonds. So this alternates pi and single bonds around. That's an aromatic ring. And then I come to another carbon that has an H, and this group here, CHO, and that's going to require a double bond O. That's an aldehyde with an H here. And then I come to a CH with an OH, so CH, and then the OH down here is an alcohol. And then I have a group that has 2 oxygens, so one's a C double bond O, as we've seen before, and the second one is an OH. Now this OH is different on the carboxylic acid than it is on the alcohol. Okay, so that's the way you can kind of break that down. I have one more example, so let's take a look at that. So in this example, again, a long string of atoms, and the problem is picking out where to make the breaks and to identify the functional groups. So if you know the functional groups, you can recognize patterns in here that are pretty obvious. If you don't know the functional groups, then it becomes pretty much guessing. So let's go ahead and see if we can see where to make the breaks. So here I said, let's make a break here with this carbon, because this is 3 single bonding groups, 3 methyls on this carbon, which is attached to this carbon. And then we see this O2 again, so that's going to be a double bond O and a single bond O, and that single bond O is going to connect over to this carbon. And this carbon has just an oxygen. This will be a double bond O also. So it almost looks at the start like it's an ester, but because of the second C double bond O, this is going to be an anhydride. All right, so that's a group that you should know. And then I come to these 2 carbons here with not much else. So again, it looks like that's probably a carbon-carbon triple bond. So I make a break right there. And then I have a CHNO2. So NO2 is a whole unit off to the side. That's going to be a nitro group. Okay, so then I'm going to make a break. Now this is a little breather right here. where you get a break because it's just a CH2. So it's connected in front, then it has the two hydrogens, and then it's connected behind. So that's just going to be an easy place to make a break, and then you kind of start over here. So when we start over, we have a carbon with an H and then an SH. So that's a whole unit. That's called a thiol. And then if I look at the next carbon, it has an H and then this unit right here, which is a C double bond OCl. This is an acid chloride. So you would want to make sure you know what an acid chloride is. And then I come to a CH and then in parentheses N3. N3 is an azido group, A-Z-I-D-O, azido group. Has a little bit of complication in structure. Two resonance structures are possible. And it has some formal charge. And then I come to another breather, CH2, so I can just kind of stop here and then start over again. So when I start over, I have an S directly connected and then a carbon. So that's a carbon-sulfur-carbon bond. It's sort of like an ether if that was an oxygen, but it's a sulfur, so we call it a thioether, or some people call it a sulfide. Okay, and then I come to another CH, but it looks a little incomplete. I should have two groups. It's connected to the carbon, and that only has a CH3, so I'm thinking this is probably an alkene, since these two carbons are going to need a fourth bond. So I make a break here. Then I have a CH and then an NO. Kind of looks almost like the NO2 way back here, but this NO is a variation where there's just a nitrogen-oxygen double bond. We call that a nitroso. Where we had the NO2 down here, we call that a nitro. That has formal charge and resonance structures. This one's just a very simple N double bond O. And that carbon is then connected to this C6H4 ring again. This is another aromatic ring. And then on the other side, we have a CH with an OH. So the OH is the alcohol that we saw before. And then when I get to the end, I have a CHO. The O cannot be, the hydrogen cannot be between the carbon and the oxygen because it can't have two bonds. This oxygen is off to the side as a double bond O, and then the H. And so this is an aldehyde group, which if you know your functional groups, you should be familiar with. So let's take a look again. Here's our long string of atoms. Here's where we made our breaks. And this is what the two-dimensional structure would look like. We have the alkane part down here, 3 methyls on the carbon. And then here is the group that has 2 carbonyls, 2 C double bond O's and oxygen in the middle. We call that an anhydride. And then we came to the alkyne right here. And then we had the CHNO2. So you can see the NO2 now has formal charge. That's a nitro group. And actually I could move the electrons in, move them over here, and that would give me a resonance structure as well. Then I get to the easy part, CH2, so I just kind of stop and get ready to start over. And then I have a CHSH. So here's the CH, and the SH is off to the side. It's sort of like an alcohol if that was an oxygen, but it's a sulfur, so we call it a thiol. Or some people say mercaptan. And then if I have a CH and then this group here, this is a C double bond OCl. So that's going to be an acid chloride. Okay? And then I come to a CHN3, and so the N3 is an azide, and we call it an azido group. And you'll notice again there's formal charge, and then there's 2 resonance structures as well. I only have 1 drawn. And then I have a CH2, so another little break. I can stop here, and then I can start over with the sulfur, and then another carbon. So I have a carbon-sulfur-carbon. We call that a sulfide, or a thioether, could also be called. And here we get to the CH and the CH3. It looks a little bit incomplete because I need a 4th bond, and that 4th bond will make this an alkene. And then I have a CH and then an NO. The NO is pretty easy. It's an N double bond O, which we call a nitroso. Okay? And then I'm ready for the next part, which happens to be the ring. So this is a 6-carbon ring alternating double and single bonds around there, which is an aromatic ring. And on the other side, I have a CH, then with an OH. In this case, the OH is an alcohol. And then I come to the end, and I have a C connected to H, and then I need to fill in the rest with this double bond O right here. And we call that an aldehyde. Okay, so these are 2 typical examples of something that I could ask on an exam in the functional groups. I tried to get most every functional group you're responsible for in these 2 examples. So, be familiar with those. And, if you know that pretty well, you can get most of this. Remember, I get partial credit. So if you get 3/4 of it right, then you get 3/4 of the points. Okay, so do do good on that. Good luck.